Questions 21 through 25 on the 2016 Grade 12 AMC 12B. Let ABCD be a unit square. Let Q1 be the midpoint of CD. For I equals 1, 2, and so on, let PI be the intersection of AQI and BD. Let QI plus 1 be the foot of the perpendicular from PI to CD. What is the sum from I to equals 1 to infinity of the area of triangle D, QI, PI? Let's label this diagram and get an understanding of what it is that they're talking about in the question stem. So first, let's label this square. I put it on the coordinate axes for a reason, and I'll get to that a little bit later. And then QI, in particular Q1, is the midpoint. So approximately here. So this is your Q1. And they are drawing two lines. The first one is from A to Q1, like that. And then another one across the diagonal from B to D. And then where they meet is your P1, like that. Okay, now before I draw in Q2, Q3 and make the diagram messy, let's just deal with what we have right now. And then later we'll draw. Now, this sum is a rather interesting one. It basically is the sum from 1 to infinity, so it goes on forever. So dq1p1 plus dq2p2 plus dq3p3 and so on, right? So the hope is that sooner rather than later we will get some sort of a pattern, and then we can use that pattern to sort of get an understanding of what the sum will be, because obviously we are not going to do it until infinity. So how are we going to approach this question? Well, I put it on a coordinate axis for a reason, because we will use these coordinates. To figure out my first area, dq1p1, like that, I obviously have to deal with this triangle right here. And what I'm going to do is drop a perpendicular from P1 down to the bottom like this. And that will be my perpendicular. And if you read the question stem carefully, you will notice that that actually becomes Q2, like that. So I obviously need to figure out what is the distance from here to here. So essentially, what are the coordinates of P? So here we go. I'm going to figure out the coordinates of P1, and we will use the following. This line and this line, wherever they intersect, that will be the coordinates of P1. So the first line from B to D, that's just y equals x. And then the second line, that one I don't know the equation, so I'll try to figure out the equation. It's a line, so it'll be of the form y is equal to mx plus b. And two coordinates are A, which is a 0, 1, and Q1 is another coordinate on that line, which is a half 0. And that's all I need to figure out the equation of a line. So subbing in the first one, I get 1 is equal to b. Subbing in the second one, I get 0 is equal to m over 2 plus b. And therefore, minus 1 is equal to m over 2. So m is equal to minus 2. And therefore, my equation is y is equal to minus 2x plus 1. To get the coordinates of P1, I set this equal to that. So x is equal to minus 2x plus 1. And therefore, 3x is equal to 1. X is equal to 1/3. And since it's on the line y is equal to x, the y coordinate is also 1/3. So that P coordinate is a 1/3, 1/3. And therefore, I can now figure out the area of the first guy. 1/2 base times height. The base is from here to here. Well, that's a half. We knew that, because Q1 is the midpoint of that unit square. And then P1, well, I just figured out the y coordinate is 1/3. So there we go. We just figured out the area of the first one. So now I'm going to do the exact same thing to figure out the next one. The next one is a line that goes from A to Q2. So it's going from A to Q2. And when that happens, that intersection point right here, this guy, that is P2. So put P2 right here, this point right there. And now, again, drop a perpendicular from P2 down to the bottom, like that. Make sure that's the right angle. And now, in the very same way, this is Q3, where it touches the x-axis. So again, we're doing the same thing. We are finding the equation of the line, and then we will find what it will intersect with, and that will be the coordinates of P2. So the points this time, 0, 1, again, A, but the coordinates of Q2, that is 1/3, 0. All right, so since you are an expert, we can do this quickly. Y is equal to mx plus b, put in the first one, and you get 1 is equal to b. Put in the second point, and you get 1/3 is equal to, or sorry, you get 0 is equal to m over 3 plus 1, and therefore minus 3 is equal to m, and therefore our equation is y is equal to minus 3x plus 1. Set that equal to this guy to get the point of intersection. You get x is equal to minus 3x plus 1, and therefore 4x is equal to 1. X is 1 over 4. And therefore the y coordinate, since it's on the line y is equal to x, will also be 1 over 4. So the coordinates of P2 are 1/4, 1/4. We can put that down here. And therefore, the area of this triangle, we can get 1/2 base times height, 1/2 base. The base is from here to here this time, and that would be pretty much the value of Q2, which was 1/3. We had calculated that earlier. And then the height is from there to there, and that is the y coordinate of P2, which is 1/4. All right. Well, I got a little bit of a pattern here, but let's just do one more just to be safe. Now, one more, so I've got to draw a line from A down to Q3, like there. And then drop a perpendicular from that point down to the bottom. That's a right angle. And that point of intersection, this guy right here, is P3. And now we do the exact same thing. So y is equal to x, y is equal to mx plus b. And then this time my points, well, the 0, 1 is always the same. But this time another point is the coordinates of Q3, which is 1/4. 1/4 and 0. So same thing, substitute, and we get, when you substitute this guy into this equation, you get 1 is equal to b, and then substitute that one, and we get 0 is equal to m over 4 plus 1, and therefore m is equal to -4. So our equation is y is equal to minus 4x plus 1. Set that equal to x because we need to find the point of intersection, and we get 5x is equal to 1, x is equal to 1/5. So that point, P3, has the coordinates 1/5, 1/5. So therefore this triangle, the area would be 1/2 base. The base is from here to here. So the coordinates of Q3 were 1/4. And then the height is this guy, the y coordinate of P3, which is 1/5. Okay, so I've got a pretty decent pattern here. And that pattern, obviously, as you can see, looks like if we were to write it in summation notation, the sum as I, or any letter, I like n better actually, n equals 2 to infinity of 1 over n times 1 over n plus 1. And don't forget the 1/2 in the middle. So this whole thing right here, this whole thing, dot, 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 goes on forever, but it's summarized beautifully into this one formula. Okay, but we still don't have to get an actual number value because all the answer choices are actual numbers. All right, let's see what this becomes. I can put the 1/2 out front. And now I've got to create a addition or subtraction, and I think that's the challenging part of the question. It's not super challenging, but a little on the difficult side. This right here is equivalent to 1 over n minus 1 over n plus 1. And you can verify that by doing the common denominator and all that. All right, so this is what is known as a telescoping series. Everything will cancel out. And I encourage you to write out the first 4 or 5 of these and see how everything cancels out. So when you do that, the only thing you're actually left with is the very first term, 1 over n, when n is equal to 2. That's it. So you get 1/2 times 1 over 2, which is 1 over 4. So it's a great question. With a little bit of patience and careful planning, you can get the answer, and that answer for 21 is B. For a certain positive integer n less than 1,000, the decimal equivalent of 1 over n is 0.ABCDEF. A repeating decimal of period 6 and the decimal equivalent of 1 over n plus 6 is 0.WXYZ, a repeating decimal of period 4. In which interval does n lie? 1 over n, they are saying, is equal to 0.ABCDEF, and this repeats. So we have to multiply both sides by 10 to the power of 6 in order to get everything in front of the decimal. The rest is going to be the same, A, B, C, D, E, F. This will keep repeating, but at least we have some numbers before 0, before the decimal point, I should say. Then what you do is you subtract these guys. And when you do, on the right side, you just get A, B, C, D, E, F, because the decimal part will basically disappear. And on this side, we will get 10 to the power of 6 over n minus 1 over n. Factor out a 1 over n, and you get 10 to the power of 6 minus 1 is A, B, C, D, E, F. And 10 to the power of 6 minus 1 is 999,999, all over n. Is A, B, C, D, E, F. So obviously n is some factor of 9999. I don't know what it is, but that's basically the conclusion. And let's factor 99999, whatever, that big long number, to see what candidates. This is 3 to the power of 3 when you do the prime factors, times 7, times 11, times 13, times 37. All right, I think that's about as far as I can go there. And now let's turn our attention to this guy, 1 over n plus 6. And they're saying that that is equal to 0.WXYZ. All right, well, let's have to multiply by 10 to the power of 4 on both sides to get the WXYZ before the decimal point. So WXYZ dot WXYZ repeat like that. And then as before, what you do is you subtract them. The right side just becomes WXYZ. The decimals basically disappear. And this part is, what is that, 1,000? Yeah. Oh, 10,000. 10,000 over n plus 6 minus 1 over n plus 6. And then factor out the 1 over n plus 6. And when you do, you get 10,000 minus 1. And therefore, that is going to be 9999 over n plus 6 is equal to WXYZ. All right, so now we've got a little bit of help, I think, because now we know that n plus 6 has got to be some factor of 9999. Well, what are the factors of 9999? Let's see here. I think that's 3 squared times 11 times 101, 101 being a prime. Okay, so 3 times 2 times 2, 12. So there's not that many. There's not that many, so since there's not that many, I'm going to list them all. So let's make a table, and let's list all the prime factors of 9999. And of course, these numbers represent n plus 6. Okay, so the prime factors look like 1, 3, 9, 11, 33, 99, 101, 303, 909, 1111, 3333, and of course 9999. So there should be 12, right? And we got 12. Okay, good. And then to get n, well, you just subtract 6 from each of these. This one's going to give you a negative. This one will give you a negative. This will give you 3, 5, 27, 93, 95, 297, 903, 1105, 3327, and 9993. Okay. Well, the question actually told us that n, if you remember, n is less than 1,000. So because n is less than 1,000, we don't have to worry about some of these. These ones we don't have to worry about. So we just have to concentrate on these guys. So we've got a few just as possibilities. Okay, well, first of all, before we even test it out, we have to see if any of these n's are possible. N has to be a prime factor of this. So it doesn't necessarily have to be prime, but it has to be a factor of this, a multiple of some primes. Okay, let's see. Is 3 a possible? And the answer is yeah, because there's 3. Okay. 5, no, because there's no 5 here. So 5 cannot work. Put a little x there. 27, I believe so, yes, because it'll be 3 cubed. 93, no, because I think that's what, 3 times 31, and there's no 31 in here, so that's no good. 95 is a factor of 5, and there's no 5, so that's not going to work. 297, what is 297? It's 27 times 11, so that will be possible, because here's 27 and here's 11, so you can definitely get that. And then 903, 903 is what, first of all? It's 3 times 7 times 43. We have a 3, we have a 7, but there's no 43 in here, so that's not going to work. Okay, so it looks like the only candidates are the 3, this guy, the 27, and the 297. Okay, it's pretty good progress. Let's see which one of those will actually work. And whichever one works is our answer. So first let's start with 3. If we have 1 over 3, 1 over n basically, where n is 3, what do we get? Well, as everybody knows, that's 0.3 repeat basically. And that is a period of 1, right? It's just one number that keeps repeating. And n, or 1 over n, if you recall, had a repeating decimal with a period of 6. So that's no good. Okay, no problem. That means it's not 3. Let's try 27. 1 over n, where n is 27. 1 over 27. Well, that is 0.03737, and so on. So as you can see, that has a period of 3. 0, 3, and 7. So that period has not matched our criteria. Okay, well, there's only one left. It's 297, so it's got to be 297, but let's just test it out. 297. 1 over 297 is 0.003367 repeat. And that has a period of 6. So there we go. Perfect. So n must be 297. And therefore, the interval that n lies in, since it is 297, is this interval right here between 201 and 400. So number 22, the answer is B. What is the volume of the region in the three-dimensional space defined by the inequalities absolute value of x plus absolute value of y plus absolute value of z is less than or equal to 1, and the absolute value of x plus the absolute value of y plus the absolute value of z minus 1 is less than or equal to 1? In this question, I think it's easier if we just concentrate on one of the quadrants, but because we're in three dimensions, they are called octants. And in particular, the one where everything's positive. X is positive, y is positive, and z is positive. When they're all positive, that inequality is reduced to just x plus y plus z is less than or equal to 1. Okay, let's graph this now. And some of you have some practice with this and some of you don't. It might be a leap of faith, but just trust me on this. This is the region bounded by the following coordinates. 1 here, 1 here, and 1 here. When we draw a shape and connecting those coordinates, it will be like this, right? And it's a three-dimensional shape, and it's basically a tetrahedron. Any coordinate inside that will satisfy this. And you can test it out if you want. For example, you can choose, say, a point like this, which is a half, or we can put a point here, which is a half, something like that, or anything, and you'll see that anything within that region will satisfy that. Okay, so I want you to be convinced of that. I know it might seem a bit abstract, but these questions, you got to be able to identify that pretty quickly. Okay, so now if I found the volume of that shape, which is a tetrahedron, I can pretty much figure out the volume of the question, what they're asking me, at least for this part. Okay, well, the volume of the tetrahedron is 1/3 the area of the base times the height. And it's pretty straightforward. The base is just this guy right here, and that's just a 1 by 1 dimensions. So 1/2 base times height is 1 times 1. And the height is just from there to there, so that's just 1. So that is a 1/6. Okay. And instead of looking at all 8 octants, I'm just looking at one because that should be sufficient. Now I have to look at this guy. That guy is essentially the same thing, but we've translated it 1 unit on the z-axis. All right, so let's plot that. So 1 unit on the z-axis, right? So approximately right here, where this is 2. And same thing, we're going to move to approximately here and approximately here. So let's now connect the dots here. What we have to do now is figure out the intersection of these two tetrahedrons. That intersection will be itself a tetrahedron, but with half the edge lengths. So instead of 1, 1, and 1, it'll be half, half, and half. So that volume is really what we're interested in, and that, of course, is 1/3 the area of the base times the height. So it's going to be 1/3 times 1/2 base times height for that small base, and that will have 1/2 and 1/2 as dimensions. So 1/2 times 1/2. And the height, before it was 1, so it's half of that now, so it'll be a half. And when you do this, you get 1/16 times 3, which is 1/48. And remember, this is just looking at what one of the 8 octants. We have to look at 8, so 8 octants will have 8 times the volume, since this is just one component in one octant. So to get the full volume, you have to multiply this by 8, And when you do, you get 8 over 48, which reduced to lowest terms is 1 over 6. And that is the answer. Number 23, it is A. There are exactly 77,000 ordered quadruples ABCD such that the greatest common divisor of ABCD is equal to 77 and the least common multiple of ABCD is equal to n. What is the smallest possible value of n? The sequence AN is defined recursively by A0 is 1. A1 is the 19th root of 2, or 2 to the 1 over 19. AN is AN minus 1 times AN minus 2 squared for n greater than or equal to 2. What is the smallest positive integer k such that the product A1, A2, dot, dot, dot until AK is an integer? Well, let's figure out a list and see what we get. A0, A1, and so on. Well, A0 they already gave me. A1 they say is 2 to the power of 1 over 19. And then A2 onwards, they've got this formula here that AN is equal to AN minus 1 times AN minus 2 all squared. Okay, so A2 would be A1, which is 2 to the 1 over 19, times A0 squared. Well, that's just 2 to the 1 over 19. Okay, so put that here, 2 to the 1 over 19. A3 is going to be A2, which is 2 to the 1 over 19, times A1 squared, which is 2 to the 1 over 19 squared. And this is going to be 2 to the 1 over 19, and then you're not going to square the exponent, right? You just multiply it, so it becomes 2 over 19, like that. And then that, of course, you just add the exponents, so that becomes 2 to the power of 3 over 19. So I'll put that in here, 2 to the power of 3 over 19. Okay, let's keep going. Let's do a few more. 8 to the 4 is 8 to the 3, which is 2 to the power of 3 over 19, times 8 to the 2 squared, so 2 to the power of 1 over 19 squared. And that's going to be 2 to the power of 3 over 19 times 2 to the power of 2 over 19, and when you add the fraction, it becomes 5 over 19. 8 to the 4, 2 to the power of 5 over 19. Okay, don't really see a pattern yet, but maybe I don't even need a pattern. Let's just figure out, we've got time, right? We're doing this as practice, so well, I'll do three more. A5, here we go. Well, A4, 2 to the 5 over 19 times A3 squared, 3 over 19, all squared. So that's going to be 2 to the 5 over 19 times 2 to the 6 over 19, and that becomes 2 to the 11 over 19. So this is 2 to the power of 11 over 19. A6, again, same story. 2 to the 11 over 19 times 2 to the 5 over 19 squared. And that is going to be 2 to the 21 over 19. Just save some steps there since you kind of get the idea by now. And we'll do one more. So this is going to be 2 to the 21 over 19, and then 2 to the 11 over 19 all squared. And when you do that math, you get 2 to the 43 over 19. All right, so it doesn't look like much of a pattern, but I did notice something by doing a lot of these, is that this exponent, whatever it is, it's always over 19. And it seems like you're taking this guy, well, right before it, and adding 2 times the one before it. So for example, let me explain what I mean by that. Let's say we had 2 to the power of a over 19 for a to k minus 1, and a to the k minus 2 is 2 to the power of b over 19. When you do a to the power of k, it looks like it's going to be a plus 2b. And you can test that out. For example, this guy was 21 plus 2 times 11, which is 22. And this one was 11 plus 2 times 5, which is 10. And 10 plus 11 was 21. So this is really sort of our formula, where the one before it, ak minus 1, is a over 19, and ak minus 2 is b over 19. All right, so based on that, let's create more of an extrapolation. Now the answer choices go up to 17, all the way from 17 to 21, so they're making us work a little bit, but that's okay. We've got time, we can do this. Our big product, A1, A2, A3, dot, 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 all the way till AK, is basically adding the exponents. It's a sum. So it'd be 2 to the power of 1 over 19, and then you're going to add up all the sums. So if you remember, this was 1, and then 1, and then 3, and then 5, 11. You're just going to add them, right? Because when you're multiplying these numbers, you're going to be adding the exponents. Simple exponent law. So it's 1 plus 1 plus 3 plus 5 plus 11 plus 21 plus 43. These are the ones we've already figured out. But I'm going to figure out, obviously, a few more. And this is going to be the next one, 85. And the way I can do it really quickly is this. You just take the previous one and add to it 2 times that. So in this case, it would be 43 plus 42, which is 85. So it's not really that complicated. 171, 341, 683, 1365. Numbers are getting larger, but I think the math is reasonable. 2731 plus 5461 plus 10925 plus 23, that is, and plus 21846. Now at this point, I'm going to stop. Why? Well, because I've got up to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This was when k is 16. Now I've got to see what happens when k is 17, because that was the first of my answer choices. So far, we're just figuring out a chain of numbers. Okay, when it's 17, then that's when we actually need to know what happens. So when it's 17, the number is as follows: 4361, 43691. Okay, let's see. 2 to the power of 1 over 19. So this would be A1, A2, all the way till A17. Now we got to add up all these guys. This, this, and this. And when you do, you get the following number, 87381. Now, what is 8731 divided by 19? It is 4599. It is an integer. So perfect. And that means we've done it. They've asked, what is the smallest possible integer k such that that product is an integer? We got the answer. We got it for k is equal to 17. And it's nice of them to have made the very first answer choice the correct one, because otherwise we'd have to go on to 18 and 19 and 20 and 21. I think they took some mercy on us. So number 25, excellent question. The answer is A.